Hey all, welcome back to my channel. So from the last three sessions we are discussing about fork join. We are discussing about fork and join, all types of fork and joins and all the ways in which you could estimate the outputs from fork and join. Okay, so all this we have been discussing in the past 3 days. So in today's session we are going to discuss about how we are going to disable this fork. That means even though we are writing some code within the fork and join, okay, so at some point of time while we are writing our code, okay, at some point of time it may happen a situation where you don't need this fork and join to work. Okay, that means the code that you are writing within this fork and join, okay, it should not work for this fork and join. So in such cases you will be using this disable fork. Okay, so the disable fork statement terminates all outstanding or active processes. Okay, let us see how this disable uh, fork is doing its work. Okay, so here the program, if you see module fork example, okay, within initial and begin I am writing like three processes. Okay, process A, process B and process C. Now if you see this process A will be executing the output at 0 display, at 0 time unit, and then at 10 time unit. Now if you come here, this is at 0 time unit and at 15 time unit. This is at 0 time unit and then 20 time units. Okay, and if you see here I have written join any, but it's not join. Okay, so you know the work of join any. What does the join any do? If at least one of the process is completed, it will come out of this particular fork and join block. Okay, now what happens? Since at least one process should complete in order for the simulator to come out of this join any and to execute the next step. Okay, until the process comes out of this fork join any, the next processes like the next threads will always be blocked. You already know that. Okay, I have already discussed about this in the previous session where I have discussed all about forks, like all differences between fork join any and fork join N. If you didn't see that, I link that in the description box, and also I link all the fork join concepts in the description box. You can go check it out there. Fork join is very important in system verilog. Okay, so that is why don't miss these sessions. If you are following me on System Verilog courses, you should compulsorily see all the sessions on Folk Join. Okay, and if you are having any doubts, you can ping me in any of my social media handles, or you can ping me in this comment box itself. Right? So now if you see here in this, at least one process should be completed in order for the compiler to come out of that particular fork join any. So if you see here, until at least one process is completed, all the display functions will be displayed. Like if you see here, all these three display functions are working at 0 time units, so the three process will be displayed. Okay, and then now coming to this fork join at 10 time units of display, because this is the least time delay, so at 10 time units process A completed at time 10. Okay, so this is printed. So that means if you see here, after the printing of this particular display, at least one process like process A completing is completed. So now what happens, the compiler will be coming out of this particular block, and then as soon as it coming out of this particular fork join any, it is seeing the command that disable fork. Okay, now what it will do, it will completely disable all the processes that are being done within this fork. Now what happens, so the 15th display, that means at 15 time units this display is blocked, and also at 20 time units this display is blocked. Why? Because I have already disabled the fork, so all the process within this fork are also disabled. Got my point? Yes, and then it will be displayed at 10 time units. The fork join any completed at time 10 units will be displayed. Clear? If you are not using this disable fork, how it is going to be working out? Like, let me show you an example here. Yes, so this is the example that we are talking about. So this is the same example what we have seen there. Okay, here I am writing three process like process A, process B, process C, and I have used a disable fork. For example, if you didn't use the disable fork, then how is it going to work out? Okay, I didn't give any disable fork. I have just written a fork join any program. Okay, and we will see how the output is going to happen here. Like if you see, have you seen the output here? Yes, so process A started at 0, B started at 0, C started at 0. Now, since this is fork join any, at least one of the process should be completed. So this process is completed at process A is completed at 10 time units. So what happens here? Process A is completed at 10 time units. So since one is completed, it will be coming out of the block. Okay, out of this particular process, three process, it will be coming out, and it is seeing there is no disable fork. So that is why here it will be displaying fork join any is completed. Okay, now what is the thing that is displayed here? If you see, fork join any is completed. So after this fork join any is completed, again the process within the fork join any are as usually displayed. Like at 15 time units B is displayed, at 20 time units C is displayed. Why? Because I didn't disable any fork here. Okay, now for this same thing, okay, if you use this disable fork, how this is going to give be how the output is going to be? Yes, so if you see here process A, B, C, okay, process A, because after process A is completed only it is going out of this fork join block. So after going out of fork join block, okay, fork join any is completed at 10 time units. But before this command I have given disable fork join any. Since I have disabled all the process within the fork join any, so the remaining two process, like if you see in the before time while we are not using any disable fork, okay, 15 and 20 time units are also displayed, process are also displayed. But here if you see, since I have disabled the fork, the 15 and 20 time units is not displayed. Okay, so that is the difference between using disable and not using disable. Hope you got an idea what is the meaning of this using disable and not. Okay, so when you want to disable the fork, that means the statement with inside what you have mentioned inside the fork and join or fork and join anything. Okay, if you want to disable, that means if you don't want the statements to be executed, then you should be using this disable fork. Okay, you can use this disable fork for either fork join or fork join in your fork join, and for anything you can use this disable fork. Okay, so this is what I'm talking about. If you don't use disable, these are the outputs. I think you have already seen in the EDA program. So these are the outputs that you will be getting if you are not using any disable fork. Okay, so this is all. Now let me ask you a small question here. Okay, for example, in internship or when you enter into some interviews or else anything, okay, an interviewer someone have asked you a question like you have to, okay, you have to write a fork join, you have to write a code for, okay, fork join any, right? This is my question. You have to write a code for fork join any, but that fork join any should act as fork join. Will it happen? Okay, I think you already know what is the difference between fork join any and fork join. Yes, so what I'm asking here is write a code in order to make fork join any to act as fork join. Okay, so this is what, right? If you know how to write, at least try it. Pause this video here and at least try for 2 to 3 minutes, or at least if you are interested and enthusiastic, try it. And if you don't know how to write, or if you can't estimate how to write, okay, then please forward this session. Okay, like please see this session until the end in order to know how I am going to use a code, how I am going to write a code in order to make my fork join any. Like the what that means is I have to write it as fork join any, but it should work as fork join. That means in fork join any, you already know that if at least one process is completed, it will be coming out of the fork join any block, and it will be executing the statements that are given below this fork join. Okay, but in case of fork join, what happens? Until all the statements within the fork join are completed, it will wait, and then after completing all the statements within the fork join only, it will be unblocking the remaining statements that were given below this fork join block. Is it or not? So now how this will act as with these qualities? Okay, by using the wait. Okay, wait keyword. So what is wait keyword means? You already know that for disabling the fork you are using disable keyword. Similarly, in order to make your fork join compiler, when it is coming out of that particular fork join block, in order to make it for stipulated period of time, you are using this wait keyword. Okay, let me just quickly go into the example to make you understand what about this wait fork, instead of telling you theoretically about what is this doing here. Okay, so here the same example again. I am taking three process. Okay, I am using join any. So if you are using join any, what is the output that you will get? So here it will be, this is executed at 0, 0 and 0, and then this will be executed at 10, then this will be executed at 10, then this is at 15, this is at 20. Is it or not? So this is the way you will be getting the code when you are using fork join any. Okay, but is it the thing that you are getting here? If you see, this will be executed at 10 actually when you are using fork join, but it is executed at 20 when, okay, when you are, for example, when you are using the, instead of fork join any, if you are using fork join here, that means you are using a join keyword. Then what happens? Here this will be executed at 0, 0, 0, 10, 15, 20. So since if you are using fork join, after executing all the process within the fork join, any fork join only, the executor will be executing the remaining remaining display units. Now this will be executed at 20. But if you see here, even though you are using fork join any, this is executing at 20. Why? Because after completing this particular, since after completion of the process A, the executor will be coming out, the simulator will be coming out of this particular block, and it will be seeing the command wait for. That means it will be waiting until all the fork and join statements are completed. It will be waiting, and then after completion of fork join of processes, then the next statement will be executed. Okay, got my point? See, the same thing, if you are not using wait, this will be the output. Yes, that is what we have discussed before. Actually, this will be executed at 10 time units if you are not using any wait. Okay, but since you are using wait, it is acting as fork join even though it is fork join any. Got my point? Yes. So this is how the thing is wait fork. Okay, the wait fork statement is used to wait for all forked process to be completed. After the addition of wait fork statement, statements after the wait fork will be executed only after forked process completion. That means until the process that is inside, that we have written inside this fork and join is completed, it will be waiting until the execution of all the process within the fork and join itself. Then only the executor will be, then the simulator will be executing the remaining processes that were mentioned after this fork join. Okay, clear? So this is about fork join, disabling and waiting of the fork join. Okay, clear? Yes, this is about all the concepts of fork join, right? Hope it is easy for you to understand about fork join. Okay, through my explanation, I have shared my views and knowledge on fork and join. Hope it is helpful for you. And if you like this video, please do like, share, and also if you have any doubts, you can comment me in any of my social media handles. Okay. So from the next sessions, we are going to talk about the most important topics in system Verilog, which is an OOPS concept. So in OOPS, we are having various things like inheritance, polymorphism, encapsulation, data abstraction. So every of these topics we are going to discuss in detail with examples. So stay tuned for that. And also, if you are new to my channel, consider subscribing my channel and hit on the notification bell also. Also, please share this to all the VLSI aspirants who are also interested to enter into design and verification domain. Right? Thank you.